In this lesson, we're talking about like and unlike fractions. And like fractions are fractions that have the same denominator. So if we look at this first example of 2/7 and 3/7, we would call these like fractions. Um, when fractions are like fractions, it's easy to determine which one's larger and which one's smaller. In this case, 2/7 is a smaller fraction, as we would have 2 out of 7 equal pieces, whereas 3/7 is a larger fraction, since we'd have 3 out of the 7 equal pieces. When we have unlike fractions, they're a little more difficult to compare. Um, and so that's one of the things we're going to work on in this section. Um, Before we work on that, let's take a quick look at a question like this. How can we tell if two fractions, such as 4/12 and 3/9, are actually equivalent fractions? Well, one way would be to reduce the fraction in the lowest terms, and if they end up being exactly the same fractions, then they must be equal. Um, but a second method would be to say, well, let's check out what we call their cross products. Now, if we were to question this, if we have 4/12, is that actually equal to 3/9? Are they the same fraction? Are they representing the same quantity? Now, cross products are formed by taking the denominator of one fraction and multiplying it by the numerator of the other fraction. So in this case, we'd go 12 times 3, and taking the denominator of this fraction and multiplying it by the numerator of the other fraction, 4 times 9. And the question is, are those equal? Are those products equal? That's why we call them cross products. So 12 times 3 is 36. 4 times 9 is 36. Since those are equal, then those two fractions must be equal. So that's a quick way of comparing two fractions. Now, sometimes the cross products are more difficult to find because the numbers are large, but we could always use that method. Now, let's take a look at this question once again. What happens if we have two fractions such as 3/16 and 5/24? It's a little more difficult to tell which one's larger and which one's smaller. So what we're going to do is we're going to rewrite these, both fractions, with the same denominator. Now, we've done this in the past, although we called it a different name. The common denominator is also the lowest common multiple of these two numbers. And if you remember back to Unit 2, you'll know that there's a whole lesson on that. It's Module 12, so if you need another reminder of how to find lowest common multiples, you can click on that one and take a quick look through those. But let me remind you of a couple things. If both numbers were prime, the common denominator would simply be the product of the two. So if we had like 5 and 7, since both of those were prime, the common denominator would be 35. But in this case, 16 isn't prime, so that's not the case. The second situation is one where one of the denominators is a multiple of the other one. So in other words, if I had something like 1/4 and 5/12, since 4 is, so if I had 1/4 and 5/12, let me write that down. Since 4 is a factor of 12, it would be easy to rewrite those with the same denominator because the common denominator would be 12. So I would just multiply this one by 3 and this one by 3, and then I could quickly see that 1/4 is smaller than 5/12. Once again, that's not the case here. So this one is the more difficult case, and that's the one that I chose to show you. So what we're going to do is we're going to start by factoring both those. So if I start with 16, always start with prime numbers. So I start with 2. I know 2 goes in there 8 times, and 2 goes into 8 4 times, and 2 goes into 4 twice, and of course 2 goes into 2 once. So 16 is 2 to the 4th power, or 2 times 2 times 2 times 2. I get that right? 2 times 2 times 2 times 2, 4 times. That's right. And then 24, well, 2 goes in there 12 times, and 2 goes into 12 6 times, and 2 goes into 6 3 times. And of course 3 goes into 3 once. So 24 is 2 cubed times 3. So my common denominator would be, remember, we list the factors that are present. There's 2's and there's 3's. And then we take the largest power. Well, Here 2 is to the 4th power, whereas here it's only to the 3rd, so we're going to write 2 to the 4th. And then 3 only appears once, so times 3. So now you can multiply that out, and if we were to multiply that out, 2 times 2 times 2 times 2 times 3, we would get 2 times 2 is 4, another 2 times 2 is 4, times 3, 4 times 4 is 16, and 16 times 3 is 48. But sometimes it's easier to leave it in this format. That's the denominator I want. And right now, when I think of these, I have 3 16ths, and I think of 16 as 2 times 2 times 2 times 2. And I have 5 24ths, and I think of that as 2 times 2 times 2 times 3. Right? Just looking at our prime factorization. If I look, I want my common denominator to be this. So compare those. What's missing? And if I look, all the 2's are there, but this one's missing the 3. So I'm going to multiply this one by 3. I have to multiply the top by 3. Take a look at this one. What's missing here compared to there? And if I look, this has 3 2's and a 3. This one has 4 2's and a 3. So I need another 2. So I'm going to multiply this one by 2, and we have to multiply the top by 2. Because remember, we have to multiply by 1, or we will change the value of that fraction. So if I do that, on this one, I'm going to have 9 over whatever that denominator works out to be. Now, we figured out it's 48, but if you were to leave it in this expanded form, I wouldn't have a problem with that. And 2 times 5 is 10 over, once again, 48, but if you left it in that expanded form, that would be fine with me too. And so if we look at those two, now that they have the same denominator, we see that 5 24ths is slightly bigger than 3 16ths, because 10 over 48 is bigger than 9 over 48. So the smaller fraction in this case is 3 16ths.